Section 10.1 System of linear equations in two variables. A system of equations is a set of equations with common variables. A system of linear equations is a system in which each equation is linear. A system of equations may have a finite number of solutions, or infinite number of solutions, or no solutions. A system is said to be consistent independent when it has a finite number of solutions, and solutions are intersection of equations, or it is consistent dependent when it has infinitely many solutions, and inconsistent when it has no solutions. We can solve a system of equations by graphing, substitution, elimination, or matrix elimination method. For the graphing method, we graph all the equations and find the intersections. For example, we graph y equals 1/2 and y equals sine of 2 pi x. We can see that all the intersections are at y equals 1/2 and x equals 1 over 12 plus k and 5 over 12 plus k for all integers k. For the substitution method, given the system, we solve the first equation for y and substitute it for y in the second equation. We then simplify the equation and solve for x to get x equals -2. Then we substitute -2 for x in the first equation to solve for y, to be -2, 5. Now -2, 5 is a possible solution, and we want to check our answer. By substituting -2 for all x's and 5 for all y's, we check to make sure that the solution we found is an actual solution and not an extraneous solution. For the elimination method, we try to eliminate one of the variables. In this case, by multiplying the first equation by 2, we get opposite coefficients for y's. And by adding the two equations, we eliminate y, so we can solve for x to get 4. Now by substituting 4 back into the first equation, we solve for y to get y equals 1. Note that we can use the second equation to find y as well. Again, possible solution is 4, 1. Now we check our solution and see that the solution is an actual solution. Here's a word problem to use system of equations. A woman rows a boat upstream from one point on a river to another point 4 miles away in 1.5 hours. The return trip traveling with the current takes only 45 minutes. How fast does she row relative to the water, and at what speed is the current flowing? Let x be the speed of rowing and y be the speed of current. Upstream, she goes at a speed of x minus y for 1.5 hours. Downstream, she goes at a speed of x plus y for 3/4 of an hour. We also know that distance equals rate times time. So the system of equations is 3/2 of x minus y equal 4 and 3/4 of x plus y equal 4. Note that we are writing times as fractions. By multiplying the first equation by 2 and the second equation by 4, we get a new system. And by adding these equations, we eliminate y variable and solve for x. Now by substituting 4 for x into any of the equations, we can solve for y to get y equal 4/3, which is approximately 1.3. So the woman rows at 4 miles per hour and the current flows at 1.3 miles per hour. Again, to check our answer, upstream is 4 miles in 1.5 hours and downstream is 4 miles in 3/4 of an hour. We had x minus y for upstream, and by substituting x and y, we get the same value. And we had x plus y for downstream, which simplifies to the same value. These are the suggested textbook problems and required ALEKS homework for section 10.1.